When we get to part E, it asks what interval is the slope of f prime negative? So since we have a graph of f prime, we are specifically looking for where f prime, this graph, is decreasing. Because to have a slope that is negative is to say the graph itself is decreasing. This graph, f prime, is decreasing, or has a negative slope, from what appears, I guess, to be negative 5 until, looks like when x is 1, it bottoms out. And then it asks for part f, what does that imply about the graph of f double prime? Well, if f prime is decreasing, its derivative, which is f double prime, that is the derivative of this graph. So if f prime is decreasing, f double prime has to be less than 0, negative. For part G, what does that imply about the graph of the original function f? Well, again, the relationship between f and f double prime is concavity. So if f double prime is negative, that means the parent graph is concave down on that interval. And we get into this idea of at what, if any, x values does f reach a relative min? Well, if f changes from decreasing to increasing, a min will result. And if f changes from decreasing to increasing, that means f prime changes from being less than 0 to greater than 0. Since we have a graph of f prime here, we can see that f prime changes from being less than 0 to being greater than 0 when x is 4. And we go the other way around to figure out when f reaches a relative max. We need f to change from increasing to decreasing. Now we don't have the graph of f, so we rely on the graph of f prime. That means f prime changes from, if f is increasing, f prime is positive, to negative values. Positive values, negative values, and the changing point is when x is negative 2. And then finally for part J, where does f have a point of inflection? Now this is a little tricky because we have a graph of f prime, and we're used to dealing with inflection points through f double prime. But how about this? F has a point of inflection when f double prime changes sign. I'm going to back up and make sure you can see these. Alright, so f has a POI when f double prime changes sign, and f double prime changes sign when when f prime changes its slope. So putting these two ideas together, f has a POI when f prime changes slope. F prime changes slope from being negative to being positive at its min value, and that happens when x equals 1.